Guys, today's lesson is on quadratic word problems. The first word problem we're going to talk about today is word problems involving area. Specifically, the area of a rectangle or a square. We all know that the formula to find the area of a rectangle or square would be length times width, in which we're going to use for these three first word problems here. They're asking us to find the dimensions of a rectangle or a square given the area and some information about the length or the width. So in problem number 1, they're telling us the area of a rectangle is 84. They don't give us any units, so we could just write that it's 84 units squared. That would be the units for area, is something squared. Inches squared, feet squared, or whatever they give you. They say that the length is 5 more than the width, and then to find the dimensions. So I know I'm going to have to use area equals length times width and substitute what we know about this rectangle into that formula. I know that the area is 84, and they tell me that the length is 5 more than the width. This sentence here is giving us an equation that we could use and substitute into our formula. Remember in previous lessons, I tell you that the word is means equal sign. So the equation that we can make there is the length equals 5 more than the width. So I would represent that as W plus 5. So right now, I know that the formula is the area equals length times width. I know the area is 84, and now I know something about the length. That equals W plus 5. The width plus 5 times the width. So right now we have the width and then W plus 5 for the length. What we're going to do now is notice that we only have one variable. We have W. We're going to distribute it to get W squared plus 5W, and we want to solve this equation. Since it has a variable squared, we know that this is a quadratic equation, and in order to solve it, we're going to have to first set it equal to 0, so we'll subtract the 84 and solve our equation that we have here. The two ways that we learned how to solve a quadratic so far is by graphing and by factoring. In this case, I would definitely use the factoring method since it's 3 terms and it's in quadratic form and the a value is 1. To write our factored form, we need to find two numbers with a product of negative 84 and a sum of 5. When the numbers become large, like 84, you might need to do some calculator work and just write down the values or the pairs of numbers that multiply to get 84 and add to get 5. For example, I know it would be 2 times 42. However, would that pair add to get 5, whether 2 is negative or whether the 42 is negative? No. So move on to maybe the next number. 3 goes into 84. (28) times. Do those two values add to get 5, whether one or the other is negative? No. I know 4 times 21. That won't work out. I know 7 goes into 84, and again, this might take a little bit of calculator work, 12 times. If the 7 is negative, I know negative 7 plus 12 is going to give me 5, so I know I'll use those for my factored form. We would set the two factors equal to 0 and get the two solutions of negative 12 and 7. However, what we're solving for here is W. That stands for now something tangible. It stands for the width of the rectangle. Therefore, the negative value won't work since you can't have a negative width. That won't exist. I know the width of the rectangle would be 7. And then I know the length would be, I could just substitute the 7 in for our length equation. I know the length is 5 more than the width. So if the width is 7, we're going to add 5 to it and get that the length is 12. So for these problems, we're using, again, the area formula, length times width. We're substituting in what we know about the rectangle in order to find the length and width of the rectangle. Let's go ahead and try the second one. It's basically the same thing as the first with a couple different numbers. They're talking about the area of a rectangle. So I know that formula is length times width. They tell me that the area is 40 units squared. And I know it would be length times width to get that. So far, since I know the area is 40, I could substitute 40 in for A, that stands for area. And they tell me the length is 6 more than the width. The word is means equal sign. So I know L stands for length, 6 more than the width would represent W plus 6. So the length could be represented as W plus 6. And I could substitute it into my formula here, times W. How would I find the area of this rectangle? I would multiply W times W plus 6, and we would get 40 as the area. So my equation makes sense. All we need to now do is distribute and solve. We're going to get a quadratic equation because when you distribute, you're going to get a term squared. In order to solve a quadratic equation, we need to set it equal to 0. So we'll be subtracting the 40 on both sides to get W squared plus 6W minus 40. There are two methods we learned how to solve quadratic equations so far, one being graphing and the other being factoring. I'm going to go ahead and factor this trinomial. Since A, or the coefficient out front, is 1, I know the factors would be the product of the C value and the sum of B. In this case, I know 10 times 4 is 40. However, we have to multiply to get negative 40 and add to 6. So that would be plus 10 and minus 4. We would set those factors equal to 0 and solve, getting the two solutions, negative 10 and positive 4 for W. Remember now, W stands for something tangible. It stands for width. So it can't be negative 10 or else the width wouldn't exist. W, or the width, is going to be 4 units. And then the length, we could use the width to plug in, is 6 more than the width. So I would add 4 plus 6 would equal 10. And since they don't give us a specific unit, you could just say the width is 4 units and the length is 10 units. Let's go ahead and take a look at the third problem here. We have the area of a square is 5 more than its perimeter. So we need to find the length of each side of the square. What do we know about squares is that each side is the same. So here we know each side is going to be the same value that we'll call x, since that's what we're looking for. Again, the area, they tell us in the first sentence, is 5 more than the perimeter. We can make an equation out of this, and remember the word is means equal sign. How am I going to represent the area of the square? I'll represent that as A is, or equals to, how should I represent 5 more than its perimeter? We will say P for perimeter plus 5. Now, they don't give us any more information than that. However, we can figure out the area and the perimeter with the information that we have now. We know that each side is going to be the same length, so we represented each side as x. The area would be length times width, or x times x, which would be x squared. And the perimeter, we would add up all the sides to get 4x. Now that we have an equation with just one variable in it, notice that we only have x in our equation, we could go ahead and solve for it. This is a quadratic equation because the term x squared is the highest exponent, and when we have a term squared, we know it would be quadratic. First thing we have to do is set it equal to 0, so I'll subtract the 4x and the 5 to set it equal to 0, and just like the previous ones, I'm going to factor to solve. Since it's a trinomial and the coefficient out front is 1, I know I need two numbers with a product of -5 and a sum of -4. That's going to be 5 times 1. One of those has to be negative. Which one would it be to add to -4? It would be -5 and +1 to get our two solutions, -1 and 5. However, we're talking about the length of a side of a square. Length cannot be negative, so we know that the sides are 5 units long. There's no need to find the length or the width in this case because since it's a square, all the sides would be the same value. The second type of quadratic word problems we're going to see today deals with the maximum height of a projectile. A projectile is basically something that is thrown or shot up into the air and it comes back down. These projectiles follow a parabolic motion, meaning the motion or the path it takes when it goes up in the air and comes back down looks like, or could be described as, a parabola, using a quadratic function to describe it. Notice that if something is shot up in the air and comes back down, we're going to have a downward or concave down facing parabola in which the equations or functions that we're going to use to describe them all have a negative first coefficient. The question that they're going to ask us about these parabolas or about these about these projectiles are what their maximum height is. A maximum height would be represented as that point of the parabola, which we all know is called the vertex. That would be the maximum value of the function. So when we are asked to find the maximum value or the maximum height of something, we know we're going to be finding the vertex. But specifically, the x value of the vertex, representing the x-axis, is always going to represent the time, and the y value of the vertex represents the height. So when they're asking for the maximum height, our answer is going to be the y value of the vertex. The x is the time it took to get to that maximum height, and the y is the how high the item went. So for example, in problem number 1, we're talking about fireworks that are fired vertically upward into the air from the ground with an initial velocity of 80 feet per second. And they want us to find the highest point reached by the projectile. They give us our function here, and one thing I want you guys to notice is that it's in function notation, and the variables they're using are h and t. H standing for the height, and t standing for time. So this beginning part is saying the height for any given time would equal the following expression given that we found t. How am I going to begin finding the vertex of this parabola or this parabolic path that these fireworks took? We're going to use the same exact skills that we learned when we were graphing. The first thing we would do is find the axis of symmetry. X equals negative b over 2a. In this case, the B value would be negative 80, and the A is negative 16. These word problems do take a little bit of calculator work. So in our calculator, we would do negative 80 divided by negative 32, and it's very common that we will get a decimal here. It's exactly 2.5. We don't want to round that decimal because we know we're going to use that value to now find the y value of the vertex, and since we don't round it, our answer will come out to be like the most accurate it could be. But before we go on to finding the y value, what does x, or the x value of the vertex, stand for? It represents time. So this 2.5 tells us it took us 2.5 seconds to get to the highest point. Now at 2.5 seconds, what was the highest point of the fireworks? How far off the ground were the fireworks? Remember, we could rewrite function notation as just y equals, and we're going to substitute the 2.5 in for t. We used to substitute it in for x, but now remember, x is representing time, the x-axis. So we're going to plug the time of 2.5 into our equation in for our t variables. Again, we're going to use our calculator to now solve for our y value of the vertex. First thing you're going to do is square 2.5, then multiply it by negative 16. That would be negative 100 plus 80 times 2.5 is going to give us 200. So the y value is going to be 100. What does the y value of the vertex represent? The height of the fireworks. And since it said feet per second in our directions, we know it was 2.5 seconds and 100 feet. So our answer would be that it took 2.5 seconds to get to the highest point, or for the fireworks to reach its highest point, and at that highest point, the fireworks reached 100 feet. Let's go on to number 2. Instead of fireworks, we're now talking about a ball that's thrown vertically upward with initial velocity of 48 feet per second. If the ball started from 8 feet off the ground, we want to determine what the ball's maximum height was. So someone threw a ball up into the air, and we want to find out how high they threw this ball. If something is thrown up in the air and comes back down to the ground, again, this follows a parabolic motion. We could represent the path of the ball as a quadratic function as they give us here. What part of the parabola would represent the maximum height? That would be the vertex. How are we going to find the vertex? Remember, we're always going to first find the axis of symmetry, that invisible vertical line that cuts the parabola in half. It is also the x value of our vertex. So in our calculator, we'll do negative 48 divided by negative 32 and get 1.5. What does the x value of the vertex represent? It represents time. The time it took the ball to reach its highest point. So I know it took 1.5 seconds for the ball to reach its highest point. But when it was there, how high did that person throw the ball? Instead of using function notation, I'll just rewrite it as y equals, and we're plugging 1.5 seconds, or the time, in for t. We're going to go ahead and use our calculator. Remember, the first thing we'll always do is the exponents, 1.5 squared, and then multiply that by negative 16, which will give us negative 36, plus 48 times 1.5 is 72, and then we'll add 8. Once we add all those values up, negative 36 plus 72 plus 8 we'll get 44. What does the y value of the vertex tell you? It tells you the height of the projectile, in this case the ball. And since in the directions it said feet per second, I know that the ball reached a maximum of 44 feet. It took 1.5 seconds for the ball to reach its highest point, and when it was at its highest point, it was at 44 feet. What I want you to do is pause the video. Once you get your answer, play the video back to double check your work. For problem number 3, finding the x value was representing the time it took for the ball to hit its maximum height. We should get 1.4 seconds, and plugging that back into the function to find the height of the ball, we should get 31.64 feet. Make sure that when you find the x value or the time that we're not rounding, because we want to use the exact decimal to get the most accurate answer for the height. When you're answering for the height, just pay attention if the directions ask you to round to a certain decimal place. If it doesn't, you could always say the height of the ball or the maximum height of the ball was about 32 feet. Please let me know if you guys have any questions about the lesson, and I'll talk to you soon.